What are your names? Cody. Cody. Henry? Yes. Is it Judy in the back?
Yeah.
Hey, Judy. And the person sitting next to you, last time was Peter, right?
Yeah.
Okay, good to see you. What's your name?
No.
No.
Nice to meet you.
Ethan.
Yes.
What's your name? CC. Nice to meet you. Okay, so we got Cody, Henry, Noah, Ethan, CC, Judy, and then your name is?
Sean.
Sean, and then Joel. And then your name is? Samantha. Is Joel?
Joel. Huh? With me?
Yeah.
Oh, Joel. Yeah.
Joel with the L at the end?
With an L.
Okay. Joel, and then Samantha in the back? This one. Hey, what's your name? What's your name?
William.
William? Hey, William. Nice to meet you.
Oh, yeah.
And the person says to me, could you say your name for me one more time?
Sorry?
Could you say your name for me one more time?
Sean.
Sean, okay, Sean and William. Okay, Sean, okay, let's see. Samantha, Joel, Sean, William, CC, Judy, Ethan, Noah, Henry, gosh, one more time?
Cody.
Cody, that's right. Okay, I'm trying. Hey, is that Joel?
Yeah.
Joel. Did you access the data hub?
Oh yeah, I did.
Okay,
Did you
good.
explain it?
Yeah, I saw it. Just want to make sure you still had it.
Yeah,
still
yeah,
had it
no
working.
worries.
Okay, great. You get a haircut?
Yeah.
Looking good, looking fresh.
Well, thank you. First the assignments weren't popping up, so I was going to email you again, and then I had to reload the server.
Yeah,
and
yeah.
it went back up again.
Okay, that's good. Good to hear. All right, let's get started. Everyone, welcome to lecture 3 of DSC 10. Fridays are always the hardest to make it onto campus, so if you're here, just glad that you're here, and hope that you find lecture today interesting and worth your time. We're gonna make this a little bigger. Okay, so at this point, every single person in the class, including people on the wait list, should have access to Gradescope, CampusWire, and DataHub. If you don't have access, email me or talk to me right away, and I'll try to give you access as soon as possible. It's really important that you get access because our first assignment is due tomorrow. Okay. Our first assignment is Lab 1. It's due tomorrow. A lot of the content on Lab 1 will be covered today in lecture, but the lab is meant to be pretty guided. There are only, if you scroll through it, it looks pretty long to scroll through, but if you haven't started it yet, I would say don't worry too much about it. There are only maybe like 12 questions total on the lab that you actually have to fill in. A lot of the text there is just for you to read, and you can run the code, but you don't have to rewrite anything for it. So it's meant to be like kind of like a guided introduction to writing code, and there are maybe about like 12 questions or so for you to fill in. At the end of the lab, there's a video about how to use DataHub and Jupyter Notebooks. If you get through the lab, you probably will have understood the basics of DataHub and Jupyter Notebooks, and the video is meant to give you a little bit more detail, and give you a few more tips on how to use it well and how to use it efficiently. Okay, one more time, homework 1 is out and it'll be due on Tuesday. And the big announcement is that there's no lecture on Monday. So on Monday, normally we have lecture, but it's July 4th. It's time to party, so I won't see you here on Monday, and I'll see you on Wednesday instead. All right, so today we have a lot of stuff to cover, so we're going to move pretty fast. We're going to be talking about code for the first time in this class. Okay, we're going to be talking about code, Jupyter Notebooks. I'll go over terms like expressions, variables, call expressions, data types, and strings. So there's a lot of programming. What I've done is I put up on the course website, if you click that link for today's lecture, you get a link to the lecture slides for today in a Jupyter Notebook format. And you can follow along by typing what I'm typing in like the little code boxes there. You don't have to worry too much. Like if you fall behind, I'm going to try to move pretty fast. So if you fall behind, like don't worry about it. I've kind of designed today's lecture so that if you like misspell something and like you can't get something to work, you can just move on with me to the next slide, and you can go back to the lecture and try to get stuff to work. Okay. But again, yeah, I would recommend that you just try to follow along, do some typing a little bit on the side while I'm doing some typing on the screen. All right. So code is like a recipe for computers. Okay, so if my sister really wants me to go to the store and buy her some milk, she'll tell me like, hey Sam, what you should do is you should get in your car, you should drive to Ralph's, go to this aisle, find the milk, find the one that's not getting close to expiration date, pick that one out from the back, and then come back home and like then we can have some milk and cookies. Okay? And code is like a lot like that for a computer instead of a person. The difference between a computer and a person, the main difference is that if, for example, I run into a traffic jam on the way to Ralph's, I know enough to kind of figure it out and like figure out what streets to go on to avoid like the nightmare that is like the La Jolla Village parking lot. But computers are not smart enough to figure things out on their own. So we have to tell them very explicitly exactly what to do in every situation. And the language that we talk to computers in is called programming languages. And we call the instructions or the recipes for the computer, and we call that code. In this class, we'll be talking about Python. Python is one programming language among many. There are lots of programming languages that are used for all sorts of things. In this class, and in many other of the data science classes, we'll be using Python. And the reason why we use Python is one, because Python is popular. My images are really small, but if I zoom into this, right now, like it used to be, okay, so back in the early days, C and C++ used to be like the big deal. And then Java came along, and then now Python is like the hot topic. So everyone's learning Python. A lot of like universities across the US have switched their introductory classes from like Java to Python. And so we're using Python as well. And the main reason why we're using Python for the data science class is because Python is probably the most popular language for data science right now. It has a variety of uses, but one of the main reasons why people use Python is because there are lots of really well-developed like machine learning libraries and like statistical modeling libraries for Python that aren't available for other programming languages. So there's a lot of advantages for using Python for data science, and you'll find that if you go into industry and become a data scientist, chances are pretty high that the team that you join, they'll be using Python as well. Okay. Python can be used for other things, so we call Python like a jackknife of programming because you can use Python for pretty much everything you want. The one caveat is that if you're trying to design like a phone application, like an iPhone or Android app, those have their own like particular language requirements. So on the iPhone, you have to learn Swift. For Android, you have to learn Java. But for pretty much everything else, you can get away with using Python, and Python is good enough for most things. Okay. If you have coded before, let's say like the introductory like CSE class here, what you probably did in those classes is you wrote code in a text editor and then you ran code using a command line terminal. Okay, so if you haven't coded before, don't worry about this. Don't worry about this at all. What I just want to point out for people who have coded before is that in traditional programming classes, you use a text editor like VS Code or Atom or Sublime Text, and then you run code using a terminal. In DSC 10, we will not be doing that, and instead we'll be using what we call a Jupyter Notebook. Jupyter Notebook is the interface that I'm using right now to run code and display slides. And I'll show you how to use the interface, and you'll be using that interface for the lab, for the homework, for the project, and pretty much everything else for the course. Okay. And the reason why we use the website DataHub is because DataHub is like a UCSD service that lets you run Jupyter without needing to install anything on your own computer. So if you've taken other programming classes before, you probably had to install some stuff on your computer, and then you might have run into some installation issues. In this class, all you need to do is visit a website, which means that you can even program for this class on your iPad, which I've seen people do. So if you like the iPad and you want to use your iPad keyboard to program for this class, that's great too, and that's the reason why we have services like DataHub for you. All right, let's talk about some code. In Python, we call expressions a combination of values, operators, and functions that evaluate to something else. Okay, let me give an example. We can use Python as a basic calculator. So if I write 12 in this cell and then hit Shift Enter, it will run and display for me the value 12. So that's not particularly interesting, but now we can do some arithmetic. So we can do 12 plus 10, and we get 22. Real quick, is this font visible? Is it small? Should I make it bigger? Give me a thumbs up if you think it should be bigger. Give me a thumbs down if you think it's good. Okay, ready, set, go. Okay, everyone can see? Okay, good. Great. Okay, so basically what Python does is it says, okay, well 12 plus 10, when I run this code, the 12 plus 10 becomes the number 22, and that's what's called an expression. If we type expressions into a cell and run it, then Python steps through every line of code we write one by one and runs them one at a time. Now, in Jupyter, what you'll see is something that looks more like this. Okay, so let me zoom out here. Let me view the toolbar. So you'll see an interface that looks more like this. If you open up the lab, you'll see this interface. And you probably saw this run button up here. So another way to run code is to hit the run button. So if I do 12 plus 1 and then press the run button, it becomes the number 13. But in reality, I really rarely use a run button. And what I normally will do is I will hold shift on my keyboard and press enter. If I hold shift on my keyboard and press enter, then it will be as if I pressed the run button without needing to move my mouse up there and click the button. So you can do whatever you want, but my personal preference is I like using shift enter. Okay. Python will also display the last expression in this cell. So let's do some arithmetic. Okay. So let's do -1 plus 3.14. That's 2.14. I can do 2 to the power of 3, and in Python, taking the exponent is times is not using. So if you try to do something like 2 to the caret of 3, this is not valid Python, or it won't work properly. What you're looking for is the times. So 2 times 3 is 8. Okay. And I can do parentheses as well. So I can do like 17 minus 14 divided by 2. And this is 1.5. All right. Now, the one thing to remember about Jupyter Notebooks is that only the last value is displayed in a cell. So every one of these boxes is called a cell in Jupyter. And whenever I run a cell, Python will run every line of code, but only display the result of the last line. So let me show you what I mean. Let's do 1 plus 1 up here. And at the bottom, I have this expression that I had before. If I run this cell, what you might think would happen is the cell will display 2 and then 1.5, but to our surprise, there's only 1.5. And the reason why that happens is because Python will run this, but it only displays the value in the last line of the cell. So even though the first line of code ran, only the last one gets displayed. All right, cool. So basic arithmetic, you can do all this stuff in Python. 2 things I want to point out to you. First thing, there's a remainder operator, which will come useful to you later on in this class. The remainder operator says, if I do 7% times 3, then give me the remainder that would happen if I divided 7 by 3. So in this case, if I divide 7 by 3, I get 7 divided by 3 is 2, and with a remainder of 1. And so this operator will give me the value of 1. It's also called the modulo operator. If you take a math course, you'll understand what modulo means. But for now, just remember that this is called remainder. And one more time, exponentiation is using times and not like the caret sign. All right. So unlike maybe like a little handheld calculator that you've used before, Python follows the ordered operations. When I was growing up, my teachers always called it PEMDAS, but I understand that some places call it BEDMAS. I had not heard that, but my friend from Canada says that's what he learned in school. So if you whether it's PEMDAS or BEDMAS, it's the same thing. The basic thing to remember is that if I write 3 times 2 to the power of 2, then what happens is Python will run 2 to the power of 2 first, and this will become 4. And then Python will do 3 times 4, and you'll get 12. So if I do 2 to the power of 2, I get the number 12. Now, oops. Oh, that's weird. Okay. If I wanted to run 3 times 2 to the power of 2 instead, then I need to wrap it in parentheses, because by order of operations in math, we do exponents before we do multiplication. So if I want to actually do the 3 times 2 first, then I need to do parentheses, 3 times 2 to the power of 2. So I get 3 times 2 is 6. 6 to the power of 2 is 36. All right. Any questions about this so far? Cool. Let's talk about variables. So in Python, oh, here are my guys. In Python, we can remember values that we want to use for later. And we can remember values by using things called variables. A variable basically lets us give a name to a piece of code. The syntax for writing variables is the name of the variable on the left, and then I write an equal sign, and then I write my expression on the right-hand side. We call this an assignment statement. And the reason why we call it an assignment statement is because another way to read this line of code is to say we're assigning the value 2 plus 3 to the variable my variable. Okay, so let me show you what I mean. Let's say I went to dinner last night with my friends and I want to figure out how much we all owe each other after the dinner. Okay? So let's say our total cost of the dinner, total bill, was, let's say, like $30 because there's like 3 people. We went to, I don't know, what's the restaurant people like? We went to In-N-Out. Okay, we went to In-N-Out. So I can use a variable to store the value of total bill. Now I can say something like, okay, well, how many people were there? There were number of people. There were 3 people there. And what that means, what this will allow me to do is now I can use this variable total bill divided by number of friends, and I get the value 10. So each of us should pay $10. Okay, so pretty simple. And the reason why we like using variables is because now we can do some more interesting stuff. Okay, so now I can say, well, it was $30 before tax. Well, what about after tax? How much should we owe after that? Well, tax in San Diego is about 8%. So I could do something like multiply by 1.08 for tax. And now all I have to do is rerun this code, and I get the value 10.8. So we all should pay $10.80. All right. You'll see me use names like this for variables. So I like to name my variables something useful to me so I can remember what they mean later on. There are a couple of caveats. So you can pretty much name variables whatever you want in Python. So if you really want to name something like, variables after all your best friends, then you can do that for sure. Like favorite TV shows, like you can go ahead and do that, and Python will be fine with it. But usually it's helpful to name it something that will help you remember what the variable will be useful for your particular problem. One caveat is we can't start variable names with a number, so I can't say something like 2 friends equals 10. This is a syntax error. So friends equals 10 is okay. Friends 2 is okay. I just can't start the variable name with a number, so this is not good. Okay. One little tip is that I can use tab to autocomplete a name. So if you remember from a few slides ago, I had a variable called total bill. Normally what I have to do is I have to go back to the cell and copy and paste my variable names over again. The other way to do this is to write total bill, is to write total, then start typing in the name, and then press the tab character on my keyboard. So I typed in the first few characters of the variable name, and I pressed the key tab. And I press tab, then you see that it automatically gets filled in to be total bill. Okay. It's convenient because sometimes I have longer variable names. Like remember I had number of people in the previous slide. So if I do num and then press tab, it fills into number of friends. Okay, so a lot of times when you write code yourself, you're going to run into what we call name errors. So let's say I typed in number of friends, but I misspelled. I put E instead of the I. Okay, so I forgot how to type number of friends. If I run this code, you'll get an error that looks like this. Okay, it's called a name error. And it's really big and scary, and it's red font, and you're going to panic, and you're think, what do I do wrong? And the thing to remember is, if you see a name error, usually that means you misspelled a variable name. And what you should do is either look back at your variables and copy and paste them so you don't make the misspelling, or use tab complete and just do num. If you do num and then I press tab, then now it'll spell correctly, and I never have to worry about misspelling. Okay. All right. So number of friends is 3. Great. Okay, so Let's go a little bit deeper into variables. When we define variables, we set the value at the time of assignment. What does that mean? Let's say I have a variable called UC, and I set it equal to 3. So now the variable UC has a value 3. If I do SD equal to 3 plus UC, now what is the value of SD? SD is, well, UC was 3, SD is 3 plus UC, which is 3, so now SD is 6. Now, man, I just want to show up on the same slide. Hold on. Let me make a new cell here. Okay, that's important. Okay. Now, let's say I do something like this. Okay, UC equals 7, and here's UC. Okay. Now, you might read this and you might think, okay, well now UC is 7, so now SD should be 10. But that's not how Python actually does it. If I look at the value of SD right now, SD is still 6. Okay. So when Python runs code, it never backtracks for you, essentially. What you should remember is that whenever you run a cell, Python will go through the lines of code one by one, and even if the variable values change, it won't go backwards and fix your variables. Okay, so this is unlike using Microsoft Excel, for instance. So if you've used Excel, you know that you could change the value of like one cell, and you have a formula that depends on the cell, that like your whole sheet can update at the same time. Python does not do that. So if I really want SD to be 10, then I need to set UC equals 7 up here. And now SD will be 10. Okay. Questions about this? Okay, so what will happen is in your notebook, you may run into this issue where, let's say I do write a piece of code that looks like this. Okay, so I have UC here, and UC is 7. And let's say I want to add 1 to UC. So I want to say UC is equal to UC plus 1. What happens when I run this code? First, UC is 7. And then Python says, okay, well right now UC is 7. So UC is equal to 7 plus 1. And now UC will be 8. And so each time I run this code, UC will go up by the value. Okay, so here UC is 8. Run it again, UC is 9. I run it again, UC is 10. Okay, so this bit of code here, every time I run it, it takes the number in UC and adds 1 to it. Now, what happens if I delete this code? So let's say I accidentally deleted this code. I look at the value UC. Well, right now UC is 10. And you're going to look at this, and this is going to happen to you in your notebooks. I guarantee it at some point during this class. You're going to be writing some code, and you're going to wonder to yourself, well, hold on. I thought UC is 7. Why is UC 10 right now? Okay. And the reason why this happens is because you wrote some code in a cell, and you might have deleted it, but that changed the value of UC forever. And if you want to change the value of UC back, then you have to run this cell again, and then you get UC equals 7. Okay, so the common thing to do here is basically what I recommend is if you run into this issue and you feel like something is wrong and your variables are not what you thought they were, then what you should really try to do first is go to the top of your notebook. So let me zoom out here. You want to go to kernel and restart and run all, and that should clear up these issues. So if I do kernel and restart and run all, then UC will be back to 7. All right. You can think of variables as boxes. Okay, so whenever we assign a variable, it's kind of like saying, okay, well, we put the value 4 in a box, and we put a label x on it so we can find the value x later on. So let me test your knowledge. Let's say that you have the following 3 lines of code. And I know you have like access to your computer, but just for now, just humor me for a bit. Just read the lines of code without running it on your own Jupyter notebook to try to see if you can predict what happens. Okay, so 3 lines of code. What are the values of side length and area after we run these 3 lines of code? So if we pasted these 3 lines in a Jupyter cell and ran the code, what would side length and area be? So try it out. Go to menti.com, scan the QR code there, and let me just see what you think. Okay, give me a thumbs up if you answered already. Thumbs up. Great. And there's Speedy. Let's take a look. Hello? What's going on here? Oh my god. My computer. It's broken. Wait. Hello? I would like to exit full screen. I would like to refresh the page. Man. Okay, let's try that. Okay, great. Everyone answered C, so let's take a look. Everyone thought silent is 7 and area is 25. And yeah, good job. Just testing your knowledge. Just a little warm-up question for you. Okay, great. Let's keep going. Okay. We'll talk about call expressions. Okay, so in Python, one math, first of all, we know that we can have functions like this that take in some input and return some output. So let's say we have this function in math that has x and y, and it calculates this thing out of x and y. So if I plug in, let's say x equals 0 and y equals 1, then you can kind of do some math in your head. Well, if x is 0, then this is 0, and this is 0, so the value of the function is -1. Python can do the same thing with functions, and there are some functions that are already built into Python. Okay, so let's take a look. When we call a function in Python, we call it a call expression. We also say we're calling a function or we're calling a method. Those are all synonymous for the same thing. The inputs to functions, we call them arguments. Okay, so when we say f of x and y, in Python we call them arguments. You'll also hear the term parameters. We use them all interchangeably. So if you keep going in this class, you'll probably hear me say, what are your parameters to this function? Or you hear me say, what are your arguments to the function? And those two things are essentially the same thing. Let me show you a function. One function in Python is called abs. And it's not because of the six-pack, it's because it takes the absolute value of a number. Okay, so we have, if you get the absolute value of -12, you get the number 12. If you get the absolute value of -1, you get the number 1. If you get the absolute value of 1, you get the value 1. So the syntax here is, okay, let's take a look. Name of the function, parentheses, and an argument inside the parentheses. So if you notice, this looks very similar to if I write f of x in math, right? If I write f of x in math, it looks like f is a function name, and then the x is like the value that I'm giving the function. In Python, it's pretty similar, except you replace f with abs, and you replace x with your input, let's say like -100, and that's how you calculate the absolute value of 100. Some functions can take in multiple arguments, so let's take a look at another one. There's a function in Python called max. Okay? If I do max 1 and 2, it gives me back the bigger of the two numbers. If I give a max of 102, it gives me back 100. So what max does is it looks at all the arguments and it says, I'll give you back the biggest one. Max can take in any number of arguments. So if I do comma 5, comma 10, comma 200, comma 150, if I run this code, max will give me back the number 200 because among all the arguments, 200 was the biggest. Okay, so the way I would read this is I would say, here, I gave max 6 arguments, and it gives me back, it returns back to me the biggest value. Of course, there's a min function. Min does the same thing except the opposite, it takes the minimum. So here, 6 arguments, but 2 is the smallest, so it gives me back 2. All right. So let me make it slightly more complicated. So a lot of times in Python, you'll see people do something like this. So you have minimum 102, but instead of 102, they have some complicated thing instead of 100. So they might have 50 plus 50. This is the same thing as the code I ran before. It's just that now 50 plus 50 is an expression. So sometimes, anytime you see a complicated expression that goes into an argument for a function, what Python will do is it will figure out what this number is first, and then it will use the minimum. So first, Python does 50 plus 50 is 100, and then it does minimum of 102, and that gives me back the number 2. Okay, any questions so far? Great, let's keep chugging. One little nifty trick you can do in Jupyter and nowhere else except for Jupyter is if you type the name of a function and use it and press the question mark sign afterward. So here, if I do max and then question mark and I run this code, what Jupyter will do is it will show me the documentation for this method right inside of my window. So you can try that out on your own. Max and then question mark. This is kind of small font, but what it does is it tells me what the function does, and in a lot of cases, it will also give me examples of how to call the function. Not this time, but when we use pandas later on this course, we'll be using that question mark a lot to just see examples of how to call pandas functions. So really helpful if you forget what the function does. You can just press question mark. It will show you the call, how to call it. It'll describe the function to you. And it's really helpful because you don't have to open up a new tab and search on Google what this function does. All right. Let me show you one more function. This function called round, which you'll have to use pretty soon. Round takes a number and rounds it. So if I do 1.22 and I round 1.22, then I get the number 1. Let's use a variable. So let's say my number, Sam's cool number, is 3.14. And let me put Sam's cool number back in. So again, I'm going to type Sam and then press tab. Expands to Sam's cool number. If I round this number, I get 3. Let me add some more decimal places. So let's say like 3.1415926. If I round that, I still get 3. But let's say that I want to round this to 2 decimal places instead of 0 decimal places. If I want to do that, what I could do is I could say, well, let's take a look at what round does. If I run this, I can see that round has a number, and it says n digits. Okay? In Python, you'll see this syntax quite a bit. So if you look at the documentation and you see this syntax where you have like n digits equals something else, this is the Python syntax for when you call this function, you can choose to include this argument or not. If I don't include it, then what will happen is it will round to the nearest integer. If I do include it by using a comma and then let's say the number 2, then it will round to 2 decimal places. Okay. And round in this case works as you would expect. So if I do something like 3.149 and round that, it rounds up to 3.15. So there are some rules about how to round numbers, and Python will follow those rules if I use the round function. All right, so let's put it all together. Let me show you what happens when Python sees you write a very complicated expression. So let's say Python, you give Python this mess of an expression here on this little slide. Let me zoom in. Okay. What Python will do is Python runs all this code from the inside out. Okay, what do I mean by that? First, Python will look at this line of code and look at the easiest thing, the most inner thing to evaluate. In this case, one easy thing to do is max of 5 and 100. So Python will do that. It will calculate 5 and 100. And when it does that, it gets the number of 100. Okay, so basically, to evaluate a piece of code that's complicated, Python will pick off the small pieces of it, figure out what the small pieces are, and then work backwards until it can figure out what your entire expression evaluates to. So in this case, max of 500, 5 and 100 is 100. So now Python says, okay, we'll replace all of this stuff with just the number 100, and let's move on. The next thing I can look at is the min of 4 and negative 2. The min of 4 and negative 2 is negative 2, so let's replace that with negative 2. Okay, so you can see that now this expression is a little bit simpler than what we started off with. Okay. Next, Python will look at the max and think, okay, well, negative 1 here is the biggest out of these 4 numbers, so I'm going to replace all of this stuff with negative 1. The absolute value of negative 1 is 1. The min of 1 and 100 is 1. So even though this expression looks complicated, Python will execute it really fast, and you don't see any of this stuff that happens internally. But what's really happening behind the scenes is Python is stepping through your code, evaluating your expression from the inside out so that it finally gets to the answer of 1. All right. Any questions about this? Okay, let's keep going. Okay, now, Python's a little bit like your phone in the sense that when you buy your phone, it comes with some apps built into it, right? So I have my phone here, and it comes with, let's say, like a mail and calendar application built into it. Python has stuff built into it too that you need to like open it up, that you need to open up for Python to use. So to use other functions, we use what's called an import statement. An import statement essentially says, okay, Python, like open up an app and use a functionality within that application. We call those apps, the analogy for apps in Python is called a module. And essentially a module is just like a bunch of functions that are just put together in one spot for you to use more easily. I'll show you the syntax. So if I want to use something from the math module, let me see here. I can import math, like so. And then, let me figure out how to make this stuff display. Well, let's do that. Okay, so if I want to call the square root function from math, I can do math dot square root of 9. And that gives me back the number 3.0. So the syntax here is, when I import a module, I use a function from the module by saying math dot square root, and then I give it the argument 9 in parentheses. And so before, we only use functions that look like let's say abs9 without anything in front of it. And the difference here is, because this function came from a module, I have to write math dot square root first, and then I can write square root. Math also has a log function. I can do log of 9, and I can do pow. And the way math.pow works is I can say something like, what's 2 to the power of 5? 2 to the power of 5 is 32, and it will return that for me as well. If I forget what a function does, let's say I call math.pow with 2, and it gives me an error. Okay? First thing I should do is read the error message. The error message says, pow expected 2 arguments, got 1. Well, that's confusing to me. I don't really know what that means. So what I can also do here is use a question mark, put a question mark after the function name and run that code. And now, this is a little small, really sorry, but what this says is we can use math.pow by doing math.pow x comma y, and what it does is it returns x to the power of y. So then I can say, oh, great. Now I remember if I want to do 2 to the power of 3, I can do 2 comma 3. Okay. Here's one more nifty trick that only works in Jupyter. So let's say I want to look at the list of functions that are in the math module. If I do math dot, and then I press the tab character, check it out. I get a list of all the functions in math. So there are a lot of functions in this module. You can do like, I don't even know what some, okay, here's cosine, Here's like e for like the constant e. Here's exponent, factorial. You can do something like log and log 10 and log 2. Here's pi here, so I can take pi. And here is the value of pi. So if you ever forget what's inside of a module or you want to look it up, you don't have to Google it. You can just press dot and then tab. Python will try to look at the module and list out all the functions available. And here's what's also cool. If I start typing out stuff, let's do S. If I do S, then the list will filter down to just the function that starts with the letter S. It's really cool. And I can be like, oh, okay, well here's SQRT for square root. And I don't have to remember how to type that every time. All right, so you try. Oh man, sorry, this is overlapping. Hopefully you still have Menti open from the previous slide. Okay, so let's say I ran x equals 3, y equals -2. Which of these pieces of code will result in an error? Which of these pieces of code will result in an error? So go to menti.com and try it out. Just think it through in your head. Again, just humor me for a minute and don't run the code yourself. Just try to guess. Look at the code and try to figure it out. Which of these result in an error? Oh, I have to clear the Menti results. Okay, let me clear them. Clear. And you may be asking at this point, Sam, why is it that you have to clear the results every single time we answer a question? And the answer to that question is because I'm a cheapo and I don't want to pay for Menti. So I have to, they limit me the number of questions I can use on a particular slide deck. I can only use like 2 questions or something like that, so I have to just use the same slide, reset it every time. If anyone wants to Menti sponsorship, or if anyone here, if Menti listens to this, give me just hook it up. Thanks. All right. Okay, anyway, try it out. All right, let's take a look. What do you think? Okay, so we have some answers for A, some answers for C. Well, I can tell you that not many people are getting this right. So how about you talk to your neighbor for 1 minute and try to figure out, just talk about what you did and why you chose it and why you don't think the other ones are working. Okay, go ahead.
Yeah, this is the same thing. I thought it was also, to be honest.
That's why I chose
Those seem to make sense, right? I mean, the second one is just 2 variables, or 2 numbers.
Yeah. I was mainly figuring out the other one, is it how it was -2?
Yeah.
Can't find any, so.
Yeah, I didn't bother checking that.
Okay, let's see. Let's just go through real quick. Give me okay, I'll just go through the letters one by one. If you think it's the letter now, just give me a thumbs up, okay? How many people think it's A? Thumbs up. How many think it's B? How many think it's C? How many think it's D? How many think it's E? Okay, got some E, got some more people on the E train. The answer is indeed E. Okay, the answer is indeed E. Let's take a look. Let's do this. X equals 3, y equals -2. The ones that error on the slide before were both A and C. Okay, so let's take a closer look at why that happened. So I have these. absolute value of x comma y. This one was not too hard for most people, it looked like. Absolute value only takes in one argument. So if you try to give it 2, it would complain. It says it takes one argument and I gave it 2. That's exactly what I did wrong, and then it'll tell me what I did wrong. Let's look at the answer B. Okay, so here's math.pow, x comma absolute value of y, and that's fine. There's nothing wrong, nothing too special about that statement. Let's go to C. So let's round x and round x max absolute value of y times 2. Okay, so here's what happened. Okay, it gives me an error. This error is very confusing. It says int object is not iterable. What this means is, well, here's what happens. Okay, so let's do it like Python would do, right? Here's y to the power of 2. Y to the power of 2 is 4. The absolute value of 4 is 4. And now this is the problem, because max needs at least 2 things to take the max of. Python's max, for whatever reason, will not be happy if you only give it one item, and this is the problem. So if I just take this out into its own line, let's look at that right now. Max of 4 is the same error, and this is the problem that was happening in that line. So the reason why the line was erroring is because max needed 2 arguments, and we only gave it 1. Okay, and just for completeness, let's look at the last line, math.pow x, math.pow y comma x. So that's fine. All right. Let's see, how are we doing on time? Got 5 minutes left. Ooh, man, got a lot of stuff to get through. Let's go fast. Talk about data types. Okay, so at this point, you have seen what we call integers and floats. Let's take a look at what they are. Okay, so an integer is a number that doesn't have a decimal place. So here's 3. This is an int. If I do type of 3, it will show me this is an integer. And if I do type of 3 plus 5, this is still an integer because 3 plus 5 is an integer 8. Okay. Let's look at floats. Floats are like integers, except they have decimal places. Okay. So if I do, let's say 4 divided by 3, this is a float, and it's called a float because it has a decimal place. So if I do type of this guy, I get the type is float. So one thing about floats is that they have decimal places, but they're not exact. So let me show you what I mean. Okay. If I do 3.0 times 4.2, I get this weird looking number. Okay. So 3.0 times 4.2 should be 12.6, but for whatever reason, Python displays it to me as 6.0000000 and like a 1 at the very end. So this is a pretty common problem when it comes to working with floats, and this happens because Python can't have 12.6 exactly. It has to be 12.6 with like a very small amount at the very end of it. Okay, so it's a pretty common problem when working with floats. It happens in any programming language that you use, and actually everything on your computer has to deal with this problem as well. It's called the floating point precision problem. So I can convert between ints and floats by using the int function. So let's say I do 2.0 plus 3. If I add an integer to a float, Python will just say, okay, well, this was a float before, let's just keep it as a float 5.0. Even if I do 2 divided by 1, 2 divided by 1 looks like an integer, but it's not an integer. It will give me 2.0. If I want an integer out of this division, then I have to do int 2 divided by 1, and that gives me back the integer type. Okay. Now, the thing to remember about integer is that it always rounds down. Okay, so let's say I do an integer 3.9. This is not the same as round. This will give me back the number 3. This is a problem when I do something like this. Let's say I do 2.51 times 100. This time, Python gives me back 250.99999x7. Okay, so this is supposed to be 251, but Python, because it can't represent floats precisely. It gives me like this thing here. And if I do the int of this, Python will always round down. So I get 250 instead of 251. So you just have to be careful when working with this. And I'll conclude with this. I'll leave you with this. So if you don't pay attention to this stuff, you can end up with some problems. Now, normally for like small things, being off by one number is not a big deal, but it does become a big deal when you're working with like rocket ships. So rocket ships need to be really precise, and in 1996, very tragically, this rocket ship exploded because the computer was rounding floats down improperly, and it didn't know where it was. It got really confused, and the whole thing just blew up. Okay, so just have to be careful about that. Okay, we're at time, so I'll see you next Wednesday. And whatever I didn't cover today, we'll move to Wednesday's lecture. So don't worry about it, we'll cover it on Wednesday. Oh wait. Oh, one more thing. If you're planning to, just a FYI, I do have office hours today from 1 to 3. If you want to come talk to me during office hours about your homework or about your lab, let me just show you real quick how to get there, okay? So I posted on Campus Flyer last night. What you need to do is you need to go to HDSI. So let's go to SDSC. Okay. You need to go here to this building. It's going to look like you want to come in from this side of the street, this side of the building. You want to come up from this side. There's some stairs there. You go up the stairs, and then on Campus Fire, there's a secret code to get into the building. Okay, so if you want to get into the building from your office hours, you have to go up to the building. There's a keypad for you to enter the code. Enter in that code and follow the rest of the instructions on Campus Fire to get there.
Should we ask you during the office hours, or can we ask you now?
You're asking me right now.
Oh, okay.
I have a bit of time.
You said it's 1 to 3?
Yeah, 1 to 3 today.
So we did.
Yeah, see you.
One question is the 6.2. So I'm not sure how, because in my understanding, there can be two interpretations of the code. It can be that Shen, so for this one, Shen can be saying that, so he identified the correlation, and then he's saying that it is possible that there's a relationship between the two. So the code maybe means that there is a causal relationships, but in the other hand, it can be that because he's not using like will, or he's not using must or something definitive, like the could can mean indicates that it's not a causal relationship. There can be some fallbacks.
Yeah. So is your confusion like, is he trying to say causal thing or not?
Yeah. Like,
okay.
I think it's.
Yeah. So when it comes to determining whether what someone else wrote is causal, what we're looking for is for that person to say like A cause B. You're looking for that statement or some implication of that statement. It's not enough to say, oh, this suggests that A could have caused B. Okay, so they have to say A caused B in order for it to be a causal statement. And if they just say A and B are linked, or if they say A and B are just associated, that's not causal.
Okay.
Yeah.
So I think that like this thing, I think this relationship, I think it's non-causal, but I'm just confused. Like you're asking the word could, so
yeah.
Should I go for like the overall understanding of the paragraph, or?
Yeah. So when we're writing like research papers, we use the word could in order to not get hated on by other researchers. So like basically we say like, oh well, A like A and B, let's say like, I don't know, like playing music makes your kids smarter. Let's say like, well, playing music could make your kids smarter because of X reasons and Y reasons, but we don't know for sure.
Okay.
But then we say could so that people don't come up back to us and say, oh, you're actually like, this is like a crazy claim, like you're a bad researcher, blah blah blah. So what we're saying is, it looks like we use the word could to say like, well, we saw the